In this video, I'm going to show you how to use the t.test function to perform the computations for a left-tailed test that's going to compare the mean of two different populations. To do this, you'd need to start by having a set of hypotheses, a null and an alternative. The null would say something like the mean from a population number 1 is the same as the mean from a population number 2, versus the alternative that would say that the mean from the first population is something less than the mean from the second population. You'd also need to decide upon a significance level, or a probability of a type 1 error for your test, and then you'd make a rule for rejecting your null hypothesis. In this case, we'll use this p-value rule. We'll just say we'll reject if our p-value happens to be smaller than our significance level. And then we need to go out and collect our samples, and we need to do that in a very particular way. We need to make sure we have an independent sample from population 1, or a simple random sample from population 1, and then we need to have independent samples from population 2, or we'll call it simple random samples from population 2. And then we need to make sure our samples from each population are independent of each other. There's no dependence between the two groups of samples there. Then we'd also need to check the distributions of our two populations. And the way we do that is we'd look at our samples and we'd say, do these guys look relatively normal or not super skewed, and they don't really have any outliers in there. And so the way we do that with my fake data here is we'd load it up and we can look at some graphs. And we can say, well, that first one actually looks pretty normal. The second one doesn't look too normal, but it does not look super skewed. It doesn't look like it has any outliers. And if we maybe look at some box plots here, same thing here, but not looking super skewed, not seeing really any outliers showing up in there. So we should be fine to go ahead and perform this test here. Now we need to ask ourselves one more question. Do we believe that the variances of these two populations are basically the same, or are we just unsure about that? Now, if we have some reason to believe that the variances are the same, when we go to use this t.test function, we'll use it one way. If we're unsure about the variances, we'll use that t.test function a different way. So if we're going to believe, or if we have some reason to believe that these variances are the same, what we'll do is we'll just load up our data in this t.test function. So I've got this guy samp1, I'll call x. I got this one called samp2, that'll be my y. I will need to tell it my alternative. In this case, we look at our alternative up here, and we have a less than sign there, so we'll say this is less. And then the last option I want to put in here is var.equal. And if I put that in there, if we're going to do it this time, we're going to believe we're going to pretend we have some reason to believe that they're the same. So we'll say true, and we'll ignore the rest of the options there. And if I run that, what I get back is this two-sample t-test. And what you'll see here is I get a test statistic, I get some degrees of freedom, I get a p-value, and then I'll see what my alternative it was. It says here my alternative that I typed in was that the true difference in means is less than 0. Well, that's the case. It'd be mu1. If I move that over, minus mu2 is less than 0. And so if I want to apply my rule, I'd look at my p-value, which is 0.004833. I'd compare that to my significance level of 0.1. I'd say that is indeed less. So based upon this, if this was actually real data, I would basically say that I have some evidence to conclude that the null hypothesis is wrong. I'd have some reason to believe that the mean from the first population is something less than the mean from the second population. Now, going back, just to save ourselves some time, we'll say to ourselves, well, what if I actually was unsure about the sizes of these variances? If I'm not sure if they're the same or not, how would that change my computations? Well, what I'd basically do is do the same sort of options at the beginning of this t.test. I just change this var.equal to false here. And if I run that, what I get back is a Welch two-sample t-test. And you'll see here that my t is my test statistic. I get some different degrees of freedom. And then I get my p-value here, which is something different than before. But still, when I look at this, I'd go back up and say, well, according to my rule, that's actually less than it. So I'd still, using this version of the rule, reject my null hypothesis. Basically, I'd say that based upon my data, I have some reason to believe that the mean from the first population's something less than the second. Now, just keep in mind that you wouldn't run both of these tests. You just do the one that you think is applicable. But that's how you could use the t.test function to perform the computations you need for a left-tailed test that compares two population means.